the next thing we're going to discuss is everything we have done so far about the performance evaluation. We did these for categorical or for a classification model, for a classification models. Now we are going just to go quickly over the performance evaluation for prediction models. The prediction models where the target variables have numerical values. So we have now numbers, right? The prediction performance of supervised data mining is assessed by computing prediction error. The error. What is the error? Is the difference between two values, the actual and the predicted value of y, which is the target variable. And we discussed some of the errors. I mean, we discussed the prediction errors and the way that these are calculated, and we talked about the residuals. And as we discussed in chapter, I think 8 or 9, not 9, 7 or 8, prediction errors are calculated in the same way as the residuals, but they are calculated using the validation dataset rather the training dataset. As with the regression models, low values for the prediction error E are preferred. And we have the definitions of all of these measures. We have the root mean square error, RMSE, we have ME, the average root is used as a measure of bias. We have mean absolute deviation, measures magnitudes without direction, models with large errors not penalized as much, MPE, measures of a prediction bias, and we have MAPA. So all of these measures are good to perform or to evaluate the performance of the prediction models. And as we said, maybe the most commonly used performance measures, the one that captures the magnitude of the errors, are the RMSE and the MAD. They both range from 0 to infinity, with the lower values indicating a better prediction model, RMSE, MAD. Because RMSE gives a relatively high weight to large errors, it's more useful when large errors are particularly undesirable. Note that RMSE will always be larger or equal to MAD. If they are equal, this only occurs if all of the errors have the same magnitude. The final point I would like to make here is there is no consistent way to define a good value for RMSE and MAD because they both assume the same units as the original target variable. For example, RMSE and MAD values will change depending on whether the purchase amounts are expressed in US dollars or in euros. This makes these measures difficult to interpret in isolation, although they are useful for model selection. So in the context of the purchase amount, the model with lowest RMSE or MAD will always be preferred over competing models, regardless of the currency used in the calculations. And the main attraction to the MAP, it's in the percentage term, and sometimes it's easy to be interpreted. So this is everything about performance evaluations, and we will do some examples over R.